The following demonstration showcases the functionality of TiCCo, Time-Centric Content Exploration. This is a joint work by Philipp Hausner, Dennis Aumiller and Michael Gertz from Heidelberg University. The main contribution of this work is an intuitive user interface to conveniently explore large document collections in a time-centric manner. Specifically, users are able to interactively query and explore content at various date granularities, exploring the content in their own pace. For the sake of this demonstration, we have chosen all English Wikipedia articles related to the American Civil War, restricting dates to the years of 1860 to 1865, the time period between the election of Abraham Lincoln and the end of the Civil War. As you can see, the interface consists of three main components, each of which we will discuss in further detail shortly. The central aspect is a timeline that shows all dates that are mentioned in the document collection, including their supergranular levels. In our demonstration, we have chosen the granularities of day, month, and year. Zooming in and out automatically adapts the presented granularities, but the users have control over the displayed levels at all times by selecting specific options in the top right corner, depending on their information need. In the lower left quadrant, a graph interface shows the co-occurrence graph with regard to a specific date. Initially displayed are the 10 entities with the highest relevance to the current date, determined by a time-centric variant of TF-IDF. Lastly, a document explorer contains the text of the underlying collection from which the co-occurrences were extracted. To demonstrate a first use case of search, users generally want to get an overview over the dataset by choosing a timestamp from a very coarse granularity, for example the year 1860. Clicking on the node retrieves the dates co-occurrence graph in the secondary interface, which reveals some first key entities. Depending on the context, users can choose to display more or less nodes. A click on an edge between two nodes, for example 1860 and election, reveals all underlying source documents in the document viewer. Similar, clicking on a single node would reveal co-occurrences with all adjacent nodes. Choosing a specific document from the sources, for example the results of the 1860 presidential election, now highlights the sentences from which the co-occurrences were extracted. Browsing through the different mentions also conveniently jumps to relevant contexts and enables users to explore details of the underlying data. Lastly, displayed content can be linked back to an external source, in our case the underlying Wikipedia article. This is highly relevant for both the integration with existing tooling as well as exploration of content within the source document by giving a broader context. Content from the document viewer is also a starting point for search, where a user can identify entities of interest in the displayed text. Such entities, for example Lincoln, can then be queried in the search bar at the top, including autocompletion. Searching for a specific entity then reveals all dates where such an entity was mentioned, neatly tying back to the original starting point of the search process. Secondly, prior knowledge about specific events can also be utilized to investigate specifics of a certain day. Choosing the 6th November of 1860, the day of the election, reveals other entities of core relevance besides Lincoln. Narrowing the search to several entities at the same time is also possible. From the graph, right-clicking entities automatically adds them to the query, revealing only those graphs where both are co-occurring. In this case, the entity sudden is indicative of the subsequent succession of sudden states, which started in the month of December of 1860. Further options to extend the search process are provided through related graphs, which are categorized into two distinct categories. On the one hand, supergranular graphs are simply referencing dates of coarser granularity. In the example of a month graph, this would be the reference to the year graph of the same year. On the other hand, related graphs are dates which are present as nodes in the current context and reference a date not currently selected. In this case, the 20th of December 1860, which was the announcement of the secession of South Carolina. To summarize, our interface presents ways to enable a coherent exploration of large document collections with a focus on the temporal aspects of events. This is enabled by a concise representation of the data in the form of a timeline, without losing access to the underlying documents that contain possibly more details which a user might be interested in. Included in this work is also a processing pipeline which gives users the possibility to provide their own datasets. Further reference on how to include and process data is given in our public GitHub repository, available under the following link. If you simply want to try out the demo yourself, Make sure to check out the website under ticco.ifi.uni-heidelberg.de. Both links are also available in the video description.